Hi, this is Teacher Chalo and welcome to our math class. Our lesson is about prime numbers, factors, and multiples. Now let us see what is prime numbers. Prime number is a whole number that can only be divided by itself and the number 1. Take note, the number itself and the number 1. Thus, a prime number has only two divisors, the number itself and the number 1. The smallest prime number is a number 2, the only even number that is prime. So what is even number? So this is a number that is in pair, like 2, 4, 6, 8, 10. All right, so this is an even number. Primes less than 50s are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47. Now, if you can look at these numbers again, these numbers are whole numbers that is only be divided by itself and number 1. Number 1 is not a prime number. Again, it's not a prime number. Now let's take some rules so it can help us determine on how to write all the numbers from 1 to 100 in 6 columns. So again, we're going to make 1 to 100 in 6 columns. So what is columns? So it's like writing 1, 2, 3, 4, 5, 6. So these are 6 numbers and it has 6 columns. Now scratch out the 1. Scratch out meaning you're going to put an X on that number because 1, it's not a prime number. Now number 3, circle the ones that you know. All right, so let's take these acronyms. My dog bites several KGB men. Now, if you are going to look at this, there are 2 letters. So we're going to put down 2 under it. And a dog, it has DOG, which is 3 letters. Bites, BITES, 5 letters. And several, there are 7 letters. And let's take K as 1 letter, and then G 1 letter, and B 1 letter, and then M, there are 3 of them, MEN. So let's put 3 down there. Now let's take a recap on this. So we'll just put it down 2, 3, it's the same number, 5, the same number, 5, and 7, it's the same number. Now for KGB, let's take these 2 numbers together. So we'll be joining them together. So let's put 11. And then the next 2 numbers, which is 1, 3, let's put them together. So that would be 3. So from this acronym, we will take my dog bites several KGB men, like 2, 3, 5, 7, 11, and 13. So these numbers are all prime numbers. We can only take 1 and the number itself when we are going to divide. Now, rule number 4 is draw a straight line down all the even numbers except 2. So again, what is even number? So this is a number that is in pair, or these are numbers that is in pair. So like 2, 4, 6, 8, 10. But again, except. So meaning when you put a straight line, what is a straight line? It's like from up going down below. So that's a straight line. So you're going to put those numbers that are even numbers a straight line except 2. So you're not going to put a straight line on that 2. Now number 5, draw a straight line down all the multiples of 3 except 3. So multiples. So multiples is like in the multiplication table. It's like 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. So you're going to put a straight line again to those 6, 9 numbers. Okay, but you're not going to put that on 3. So I'll be showing you a picture on that, on how to do it. Now again, we'll take rule number 6, the last one. draw diagonal lines for all the multiples of 5 and 7. Diagonal lines. So how to do that? It's like from the left and going this way. Just like drawing a one part of the x. All right, so and except 5 and 7. So multiples of 5 is like 5 multiplied by 1 is 5, 5 multiplied by 2, it's 10. So these are multiples of 5, like 7 multiplied by 1 is 7, 7 multiplied by 2 is 14. So these are multiples of 7. So let's have the example. So it says that in number 1 there, it's write all the numbers from 1 to 100 in 6 columns. So we have here from 1, 2, 3, 4, 5, 6, and you can see multiples of 6, like 6 by 1 is 6, 6 multiplied by 2 is 12, 6 by multiplied by 3 is 18. So these numbers are multiples of 6. All right. Now, again, it says number 2, then scratch out the 1 because 1 is not a prime number. So you scratch, you put a red mark in here. And number 2, circle the ones you do know. So meaning the one we have learned already. So from the acronym that we talk about, my dog bites several KGB men. So we have 2. So we circle it with a green. So we know it already. And then tray with a dog, there are 3 letters, and then bites, which are 5 letters. So put it there. And then 7, several. So we circle. And then the KG, that's we took the 2 numbers together. So we have 11, and then also the B, and that is 1, and men, that is 3. So we have 1 and 3, we put together, that is 13. Now, draw a straight line down all the even numbers except 2. So even numbers, what are the even numbers? So we've got in pairs, so 2, 4, and 6. So we take down all these even numbers except 2. So we start here except 2. So we will start by 8. So that is 8 going to 98. All right, so these are even numbers under 2. And then we go to 4. So we started with 4 and then going to 100. So again, it is an even number, or these are even numbers. And then let's take then 6 down to 96. So we have a straight line. Now next number will be draw a straight line down all the multiples of 3 except 3. So what are the multiples of 3? So these are 3 except 3. So again, you're not going to include it. So you start with number 9 down to 99. Now the last one, it says draw diagonal lines for all multiples of 5 and 7 except 5 and 7. So let's take first with 5. 5 multiplied by 1 is 5. 5 multiplied by 2 is 10. So again, 5 multiplied by 3, 15, and it goes down to 5 multiplied by 5. But except 5. So you're not going to include 5. So we will start 10, 15, 20, 25. So what else? So we've got 30, 35, 40, 45, 50, and 55. And we have another one, 50, 65, 70, 75, got 80 and 85. And then 90, 95, and then 100. So again, these are multiples of 5, except 5. Now, it says, and also diagonals for all the multiples of 7. So let's start with 7, except 7. So except 7, so we're not going to make a diagonal line here. So let's have 20. We have here 49. All right. So 25 is not, it's the multiples of 5. So let's take 7 by 7, we get 49. Or 7 multiplied by 7 is 49. And then 7 multiplied by 8. So we have 56. And going to 63, 70, and 77, and 84. And we have also 91, 98. Okay. So again, these are diagonals that is multiples of 7 except 7. Right, so that if you can see there are circled numbers in green here. So from this column 1, the prime number here is 7, 13, 19, 31, and let's take a look at that. 31, 37, 43, and 61, 67, 73, 79, 97. And we have from this column, we've got 2 only, and then 3 in this column. And then in this next column on 5, we've got 5, 11, 17, 23, 29, 41, 47, 53, 59, 71, 83, and 89. So from this, in the sixth column, we don't have any. These are all not prime numbers. So again, from 1 to 100, we've got prime numbers with this circled green color. All right, so let's move on. Okay, let's take a look first to the next one. All right, so I'm going to make a bit fast in here. The next presentation will be about, let us see, an example, taking the examples of prime numbers. So we're going to know if these numbers are prime. So let's take this number 13 and 51. So the answer is 13 divided by 1 is 13. We can't find any numbers to that can divide in it. And 13 divided by 13 is 1. So again, 13 can only be divided by these two numbers, 1 and 13. So these are two dividers or divisors. So 13 is a prime number because only two numbers that we can actually divide it. There's no other. Okay, 51. So if you can see in here, 51 divided 1 is 51. And then we have 51 divided 3 is 17. 51 divided by 17 is 3. And then 51 divided by 51, this is 1. Okay, it's not 51, it's 1. So 51, if you can see, this number is divisible by 1 here. We've got 3, 17, and 51. So we've got 4 divisors. So therefore, 51 is not the prime numbers because we have more than 2. All right, so again, prime numbers, we can only divide it, divisible divide by its number itself and the number 1. Okay, next. The next topic is a factor. Factor is a number that is given, okay? That the number is a multiple of the number accurately. Accurately meaning there is this is a number that can actually divide a given number accurately. So meaning there is no remainder. So let's take a look. 1 in itself is a factor of any given number. Again, right? So 1 can divisible divide any number. So it's given number. Now find all the factors of 18 and 50. So take a look at how we can find all the factors of this number. So we have 18 divided by 1, we got 18. And then 18 divided 2, we have 9. And then 18 divided 3, we can have 6. 18 divided by 6, we can have 3. And 18 divided by 9, we can have 2. And 18 divided by 18, it's 1. So if you can see 1, 2, 3, 4, 5, 6. So we have at least 6 factors or numbers that we can divide on this given number. So 18 can be divided by this. So therefore, the factors of 18 are these numbers: 1, 2, 3, 6, 9, and 18. So we can have more than 1 or 2. We get actually 6. Let's take 50. 50 divided by 1 is 50. 50 divided by 2 is 25. 50 divided by 5 is 10. 50 divided by 10, we can have 5. And 50 divided by 25, we can have 2. And 50 divided by 50, then we can have 1. So again, you can have more than 2 numbers that you can divide accurately. Okay, there is no remainder. So this number 50, we can have 1, 2, 5, 10, 25, and 50 factors. So therefore, these are the factors of 50. Okay, next, we have to determine whether a number is a whole number of factors to another. So let's take a look. 7 is a factor of 119. Okay, so 119 divided by 7, we have 17. So 119 can be divided exactly by 7. So 7 is a factor of 119. Exactly, meaning there is no remainder. 4 is a factor of 599. So it says that 599 cannot be divided exactly by 4. So meaning there is a remainder on that. So 4 is not a factor to 599. Next, we're going to talk about prime factor. So what is prime factor? These are numbers that can divide accurately of a given number, but take note is prime. So let's go back to what is prime. So these numbers are can only divide a given whole number by the number itself and the number one. So we're going to take this prime factors of a number is the prime factors of the number. So let's identify the prime factors of the list of factors I'm going to show you. So given 1, 2, 4, 7, 8, 14, and 56 are the factors of 56. Okay, identify all prime factors of 56. So this is it. Among the factors of 56, okay, if you can see, we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 7, 18, 14, and then 56. At least we have 2, 4, 6, 7 factors that we can divide accurately on 56. But then we're going to find prime factor. So among these numbers, only 2 and 7 are prime factor because 1 is not a prime number. 4 is an even number. All right. 8 is an even number. So even numbers, these are in pairs, 2, 4, 6, 18. And then 14 is in pairs. Okay. And 56 is in pairs. So from these numbers, the prime factor, the 2 is the smallest prime factor. So let's take this and 7. So we have only 2 prime factors of 56. All right, let's move on. Finding the prime factors of whole numbers. So let's take prime factor numbers of 100. So let us see. So we will have at least 3 methods of finding prime factors of the given number 100. So let's take all the factors of 100. So what are those? We have 100 divided by 100, 100. So we can have 1. So we can have 2, 2. We can have 4, 5, 10, 20, 25, and 50. And also, of course, 100. Just like 100 divided by 100, we got 1. So among all these factors, how many factors do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got at least 9 factors in this number 100. So among all of this, we're going to get only the prime factor. So again, 1 is not a prime. So let's not going to take that. 2 is the smallest prime number. So we will take that. 4 and 10 and 20 and 25 and 50, these are numbers in pairs. So we're not going to take that. So among these numbers, we are going to have 2, okay, and 5. So these 2 numbers are the only prime number or prime factors of 100. So the answer is 2 and 5. Let's take the method 2. So we'll be using an algorithm. It's like a short division. So it's like an algorithm. We're going to use this one to identify if you can have these prime factors. So again, let's take or use prime numbers first. So 100 divided by 2, 2 is a prime. So we have 50, 50 divided by 2, which is a prime. Okay, we can have 25, 25 divided by 5, we can have 5, and then 5 divided by 5. Then we have 1. So we call this one as a algorithm or a short division. So therefore, from this number, we have 2, 2, 5, 5. So since we have two the same numbers, we just take one of that. So our prime factor, we have 2, and then take one of this, we have 5. So the prime factors of 100 are 2 and 5. But the last method is using a diagram or a diagram of trees, or sometimes you call this factor tree diagram. So we will be putting 100 on top, and then we're going to look for factors of 100. So we can have 2 multiplied by 2 multiplied by 50. Then we can have 100, of course. So 2 we cannot divide anymore, so we'll just take down 2 down there. And then 50 multiples or factors of 50, we can have 25 multiplied by 2. So we have there's 2 times 2 times 25. We can have, again, go back to 100. Now we cannot find of any numbers that we can divide 2. So we'll take down 2 here, going down, and 2 going down. And then 25, we can still have factors of 25, which is 5 multiplied by 5. So you'll get 25. So therefore, 2 multiplied by 2 multiplied by 5 multiplied by 5. These are factors of 100. So let's take one of these two 2's and then one of these two 5's. So from this diagram, the prime factors of 100 are 2 and 5. So going back to method 1, method 2, and method 3, we can show different method of getting prime factors of 100. But again, our final answer, we can have only prime factors of 100 are 2 and 5. So we can, now you can choose according to your like, which one do you think will gives you shorter time, or you find it easier to use in finding prime factors. So you can take any of this method. 1 will be okay, 2 will be okay, 3 will be okay. As long as when you are going to be asked, you can describe how you get it, and the final answer will be the same. All right, so this is the last one. Multiples of a whole number is the product of the number of any other whole number except 0. So again, what is multiples? These are numbers in the multiplication table. It's like 1 times 1 equals 1, 1 times 2 equals 2, 2 times 1 is equals 2, 2 times 2 equals 4, 2 times 3 equals 6, 3 times 1 equals 1, and so on and so on. So this is what we call multiples. Okay, multiple of a number, let's take n, is in the form of nk, where k is equal to 1, 2, 3, 4. So for example, as I've mentioned, multiply by 3. 3 times 1, 3 times 2, 3 times 3, 3 times 4. So these numbers, you can find it in the multiplication table. All right, so whole number is divisible by another number if the balance is 0. All right, so we've finished with prime numbers, factors, and multiples. So that will be the end of the lesson for today. So see you next time.